A fact family is a group of 4 math facts made from 3 numbers. We're going to use our multiplication and division fact families to explore patterns for dividing with negatives. We'll start with using all positive values and write a fact family for positive 3, positive 8, and positive 24. Starting with multiplication, we know that 3 times 8 gives us 24. We also know that multiplication is commutative. That means if we change the order, we get the same result. So I could also write that positive 8 times positive 3 gives me positive 24. We also know that division is the reverse of multiplication. So I can reverse each of these statements to come up with my division facts. Reversing the first one tells me that positive 24 divided by positive 8 gives me positive 3. Reversing the second statement tells me that positive 24 divided by positive 3 gives me positive 8. Now let's go and start changing the signs. Instead, we're going to have negative 3 and negative 8, but we'll keep our positive 24. We know from multiplying with negatives that multiplying together a negative times a negative is going to give us a positive. So negative 3 times negative 8 will give us positive 24. Multiplication is still commutative, so I can still change the order and have negative 8 times negative 3 to give us positive 24. Division is still the reverse of multiplication, so I can reverse my first statement to give us one of our division facts. Positive 24 divided by negative 8 is going to give us negative 3. Reversing the other statement, we have positive 24 divided by negative 3 to give us negative 8. We're going to write one more set of fact families. Now our 3 is going to be positive, our 8 is going to be negative, and our 24 is going to be negative. We know from our rules of multiplying with negatives that when the signs don't match, that the product's going to be negative. So this means positive 3 times negative 8 will give us negative 24. And again, we can reverse that statement to have negative 8 times positive 3 give us negative 24. To write our division statements, I would then have negative 24 divided by negative 8 to give us positive 3. And our last one would be negative 24 divided by positive 3 to give us negative 8. Now if we look at the division side, we can see that we have all the possible combinations. We have positive divided by positive, positive divided by negative, negative divided by negative, and negative divided by positive. If we look where our signs match and the positive divided by positive and the negative divided by negative, our quotient came out to be positive. That's the same pattern we found when multiplying with negative. When our signs match, our result is positive. We can also see that when our signs don't match, positive divided by negative or negative divided by positive, that our quotient comes out to be negative. Again, that matches with what we know from multiplication. When the signs don't match, the result comes out to be negative. So when we divide with negatives, we really just need to follow the same rules that we have for multiplying with negatives. Let's put our patterns for dividing with negatives into an algorithm. First off, when we need to divide with negatives, we start out by ignoring the signs and simply dividing the values. If our signs match, positive divided by positive or negative divided by negative, then our quotient is also positive. If our signs don't match, positive divided by negative or negative divided by positive, then our quotient is also negative. Let's test that out with a few different problems here. We'll start out with positive 1,250 divided by negative 50. Well, to solve that, I have 1,250 divided by 50. To solve that, I do 50 goes into 125 twice, subtract 100. When I do, that leaves me with 25, bring down my 0. 50 goes into 250 5 times, and then I'll have none left over. Since my signs don't match, I have a positive 1,250 and a negative 50. That means my 25 is going to be a negative 25. In our next problem, I have a whole number divided by a fraction, 5 divided by 1/2. So that means I have to follow my dividing fraction rules. So I need to make 5 into a fraction of 5 over 1 and multiply by the reciprocal. The reciprocal of 1/2 is 2 over 1. So I have 5 over 1 times 2 over 1. 5 times 2 gives me 10. 1 times 1 gives me 1. 10 over 1 then simplifies to just 10. Since both of these are positive, 5 divided by 1/2, that means my solution is also going to come out to be positive since my signs match. Down here, I have 2 negative fractions. Negative 3/8 divided by negative 1/4. So again, I'm following my rules for dividing fractions. So I have 3/8 multiplied by the reciprocal, which is going to be 4 over 1. Multiply my numerators together. 3 times 4 gives me 12. Multiply my denominators. 8 times 1 gives me 8. 12 over 8 can then simplify to 1 4/8. We aren't quite in lowest terms yet because 1 4/8 can simplify to 1 1/2. Again, my signs match. So that means my 1 1/2 is going to be a positive 1 1/2. In our last problem, we're dividing negatives. Negative 1 44 hundredths divided by positive 3/10. So when I set that up, I have 1 44 hundredths in my dividend and 3/10 in my divisor. Well, the first thing I need to do is move my decimal out of my divisor. Since that moved one place to the right, I need to move my decimal one place to the right in my dividend, and then I can go ahead and move it up into my quotient. Now I can divide. 3 goes into 14 4 times, so I subtract 12. 3 goes into 24 8 times, and from there, I have none left over. Since my signs don't match, I have a negative divided by a positive. That means my 4 8/10 is going to be a negative 4 8/10.